Welcome to the video explanation of the Chapter 6 Test Review Answer Key. So as we go through these problems, I'm going to give you a couple things to keep in mind and remember for the upcoming Chapter 6 test. So first off, anytime that we are solving and graphing the solution on a number line for an inequality, you want to keep in mind if the symbol is simply a greater than or a less than, you would use an open circle at the value when you're graphing. If it is greater than or equal to or a less than or equal to, you end up using a filled in circle. And then remember, anytime we're multiplying or dividing by a negative value, you would flip the inequality sign. So if it was greater than, when we divide by the negative, it turns into a less than. So looking back at number 1, we simply have to subtract 9 from each side. So we end up with x is greater than -4. So our graph is right here, arrow going to the side greater than -4. Number 2, a divided by 5 is less than -2. Multiply both sides by 5. A is less than -10, so the arrow would go to the left for less than -10. In 3, we have to subtract 4 from each side and then divide by the -3 to get x alone. So 12 divided by -3 is a -4. Remember to flip the inequality, so your final answer is x is less than or equal to -4. So we'd have a filled in circle at -4 and the arrow going to the values less than -4. In 4, subtract 6 from each side and then divide by the 7. So we end up with x is greater than or equal to a -3. So again, filled in circle at the value, -3, arrow going to the right because we want values greater than. In 5, you want to get your variable to one side. So I subtracted both sides by 2n, and we have n minus 7 is less than 5. Add 7 to each side, and n is less than 12. Open circle at 12, arrow going to the left. In 6, you need to use the distributive property first. So 4 times x and 4 times -3. So we have 4x minus 12 is greater than or equal to -20. Add 12 to each side, and then divide by 4. And you have x is greater than or equal to -2. So filled in circle at -2, arrow going to the right. Then our last few on this page, 7, 8, 9, and 10. For 7, we have an OR statement, so you want to solve them separately. So we'll do the inequality on the left, then the one on the right. So add 5, divide by the 7 for v is greater than or equal to 10. And on our other one, add 2 to each side, divide by the -3, so you have to flip the inequality, and you have v is less than or equal to -3. So we'd have filled in circles at -3 and 10. Greater than 10 would be to the right for our arrow. Less than -3 would go to the left. So our arrows go away from each other. In 8, our 3p minus 6 is in between two inequalities. So that means I have to add 6 to all 3 parts. So we end up with -30 is less than 3p is less than -9. And then divide all parts by 3 to get p alone in the middle. So we have p is greater than -10 and less than -3. So we'd have open circles at -10 and -3 and a line combining them. In 9, we have the absolute value of p plus 4 is less than or equal to 8. So when we solve that, we would set it up as the value inside the absolute value, p plus 4, less than or equal to 8. And then we'd also use the p plus 4 is greater than or equal to -8. Then we'd want to solve both for p. So p is less than or equal to 4, and p is greater than or equal to -12. So filled in circle at -12 and 4, and it would be combining because from -12 we'd be going right, and from 4 we'd be going left. Then in number 10, before we separate into two parts, we want to get the absolute value alone. So we're going to add 3 to each side. So we have the absolute value x minus 2 is greater than 8. So to solve that, we'd have x minus 2 is greater than 8, and x minus 2 is less than -8. So we end up with x being greater than 10, and x is less than a -6. So open circles at both -6 and 10. Less than -6 would go left, greater than 10 would go right. Now, 11 and 12, we're checking, is the ordered pair a solution of the inequality? So remember, ordered pairs are always written as x comma y. So we're going to substitute in the x and y values and check if the inequality is true. So in number 11, we end up with 2 minus 8, and we're checking if that's less than or equal to 6. So is -6 less than or equal to 6? Yes, it is, which means 2 comma 8 is a solution. In 12, 5x plus 4y is greater than -12. We're checking is -3, -4 a solution. So we'll substitute the -3 in for x, the -4 for y. So we end up with -15 plus -16. And is that greater than a -12? So is -31 greater than -12? Nope, it is not, because -31 is further into the negatives, so it's a smaller value. So in that case, it is not a solution. 13, 14, 15, and 16 are all graphing inequalities. So in this case, we're not using the number line, we're using a coordinate plane to graph. If we have y is less than or equal to 5, if we were to graph the line y equals 5, it would be a horizontal line at 5. Because it's or equal to, we have a filled in line. Then the value's less than or equal to 5. So anything below this line is less than 5, so we would shade below the line. In 14, x is less than -2. So we'd have a vertical dashed line at -2. It's hard to see this thing should be dashed, but it is. And then the -2, make sure you're on the left, not the right, of 0, 0. And the values less than -2 would be to the left of that line, so we shade to the left. In 15, it's already in y equals mx plus b slope-intercept form. So we're going to start at the y-intercept to graph, -4. And from that point, we'll follow the slope of 2 over 3. So up 2, right 3. So starting at a -4, from that point, you go up 2, right 3. Then again, up 2, right 3. Graph your line, solid line, because it's an or equal to. And then for the shading, we want to check 0, 0 if it's a solution. So put in a 0 for x and y. So is 0 greater than or equal to 2/3 times 0 minus 4? So is 0 greater than or equal to -4? Yes, it is. So we would shade on the side toward 0, 0. And then in 16, 9x minus 3y is greater than 18. We want to get y alone. So first, we're going to subtract 9x from each side. So we have -3y is greater than 18 minus 9x. Divide all terms by a -3, so our inequality flips, and we have y is less than 3x minus 6. So my y-intercept's a -6, slope is 3 over 1. So we would start at 0, -6, go up 3, right 1 for our next point, up 3, right 1, and then you can draw your dashed line, because it's just less than, not or equal to, and then to check 0, 0 for the shading. So we can put 0, 0 in for x and y. So is 0 less than 3 times 0 minus 6? Is 0 less than a -6? No, it is not. So we would shade to the side opposite where 0, 0 is. So if 0, 0 is on the left, you would shade on the right of that line. And then our last problem on the review, the box and whisker problem. So the first thing you want to do is take your list and write it in order least to greatest. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So you want to make sure you have 9 values in your list. Then you know the whiskers are the largest and smallest values. So our whiskers would be at 10 and 21. The number in the middle is our median, and in this case, only one value is in the middle, so the median is 18. For quartile 1, we want the median of the lower half of the list, so we're looking at 10, 14, 15, 17. The median would be 14 plus 15 divided by 2, which is 14.5 for quartile 1. For quartile 2, we're looking at the right side, so 19, 19, 20, 21. So the median's between 19 and 20. So 19 plus 20 divided by 2 is 19.5. So quartile 3 is at 19.5. So then when we create our box and whisker plot, whisker at 10, whisker at 21, the segment for the median at 18, segment for Q1 at 14.5, and the segment for Q3 at 19.5. Then you just draw the 2 lines to finalize the box, add the little segments for the whiskers, and you're done. So if you have any questions before the test on Monday, feel free to reach out to me via email or stop by my classroom, and we can take some time to go through any questions that you may have.